Hey, welcome to Year Out of Code. My name is Martijn, and this is part 2 of the weird gyroid ball tutorial that I started last time. And in this part we're going to add some cool lighting effects to this thing to really kind of polish it up and make it look super cool. So if that interests you, then you should definitely stick around. If you haven't checked out part 1, then I recommend going to check out that first. The link is in the description. Okay, so let's get started. So what are we going to do here? Okay, the first thing that I want to do is I want to make glitters for the ground. So like this ground is some sort of sand surface or something like that, and I want some glitters inside of here. And so for that, I am going to go. Let's go all the way down here, and let's just cut out our graphic for a second by multiplying everything by 0 to make it black. And then let's add a function, call it glitter, that takes as an input just a UV coordinate, an X and a Y. As an output is going to give us a bunch of glitter. And so let's make that function. So I'm going to go over here, I'm going to say float glitter. That's going to take as an input a position in 2 dimensions, as an output is going to give us a bunch of glitters. So what is a glitter? Well, I'm going to just approximate it by a little disc, well, lots of little white discs. And so how do we make a disc? Well, we make a disc just by the same way in 3D as you make a sphere. That's in 2D you make a disc by doing that. Like, let's say you get the distance from that point to the origin, and then you subtract the radius of the disc, and that's your disc. So, and now, well, I can visualize that by itself. That just gives me this, right? Because the closer you are to the center, the smaller the distance, the darker the color. But we want to cut this into a disk, so I'm going to do float M, and I'm going to use a smooth step for that. And this, by the way, this is the same as this, but because I use smooth step so often, I made a define over here, so I can just use S instead of smooth step. Okay, so S, and then I'm going to say D. Actually, you know what? Let me just take this out over here, and then over here I could say 0.3 and 0.0. No, hang on a second. Why is that going like? Oh, because I need M over here, right? And that's my little glitter. But we don't want just one glitter. We want lots and lots of glitters. So for that, I'm going to divide the screen up into many different boxes. So right now my UV goes from -0.5 to 0.5, right? And the origin is in the middle. So now what I can do is I can say P equals fract P times 10, let's say. So now this P, well, I can even take this out. I can say P times equals 10 over here. And then over here, just say the fract of P. And so if before it went from -0.5 to 0.5, then after multiplying by 10, it goes from -5 to 5. And then this fract just cuts it up into boxes. So it goes from 0 to 1, 0 to 1, 0 to 1, 0 to 1, 10 times. Okay, so and what that looks like is this. And now you see there's a bunch of boxes, and then inside of each box, in the corner of the box, we have this this glitter that is cut off, and that is because the origin of each box is in the lower left corner. So we want the origin to be in the middle. So, well, that's simple enough. We can just subtract 0.5 from the coordinate, and that gets us the glitter in the middle. Okay, now we want all these glitters to have different sizes, and for that we need to have a different seed value for each box to modulate the size. And to get a seed value for the box, I'm going to make an ID. So I'm going to say vec2id equals the floor of P, and you have to be careful to do that actually before this, because otherwise, because here this P gets sliced up and then the ID would not be good anymore. So now we have an ID, and now we need to take that ID and turn that into a random or pseudo-random value. And for that, I'm going to make a function, call it hash21, and it's going to take as an input a vector 2, and as an output, it's going to give me a float. That's why hash just means it's a function that like jumbles up numbers, and basically this jumbles up two numbers in order to give you one jumbled number. That's why it's hash21. And there are multiple ways of doing this. The way I'm going to do it is like this. I'm going to multiply my my number or my vector by some dummy numbers to make them large, and then use the frac to make it that both x and y are somewhere between 0 and 1. And then I'm going to add to that the dot product of p and p plus some other number, and then I'm going to return the fractional component of p dot x times p dot y. This is just some screwing around with numbers to jumble them up so much that it looks like the result is random, even though it really isn't. So let's have a look at that. Well, we could check out if the random function works by just saying m equals hash21 of p, let's say, and that gives us a bunch of randomness. You can see a grid here, and that's because for every grid cell it goes through the same input values as p, and that's why the output values are also the same. But this looks good to me. It's just that we're not going to do that. We're going to do it of ID instead, right? So if we do a hash of the ID, then every box has a different value. And we can use that. So let me just go, let's say, over here. I call this N for noise. So this is get pseudo random value between 0 and 1. Okay, because we can use that to make smaller glitters. So right now all our glitters are 0.3, and actually I can make it all the way to 0.5, let's say, and then I can make them smaller, right? So, well, if my n value goes between 0 and 1, then I can just multiply this to modulate the size of all of the sparkles. Okay, so now I want these sparkles to actually sparkle, and in order to do that, I am going to use a sine wave. So if I multiply this by a sine, let's say the sine of I time, and now a sine goes between minus 1 and 1. I don't want that. I need it to go between 0 and 1. So for that, I'm going to just actually here, let me just go to Desmos and show you over here. So normally the sine of x would be like this. It goes from +1 to -1. So I don't want that. So I'm going to shift it. So I'm going to first multiply by 0.5. So now it goes from +0.5 to -0.5, and I'm going to add 0.5. So now it's between 1 and 0. And so let's have a look. 1 and 0. So times 0.5 plus 0.5. And so now I get it that all of my sparkles at the same time fade in and out. And that's obviously not ideal. So I want it to be a pulse. And so in order to get a pulse, I can just raise this to a power. Because watch what happens because values that are close to 1 that are raised to a power will stay close to 1, but values that are close to 0, the closer it is to 0, the more it will be like, it will be glued to 0 after it's been multiplied by itself. So if I do this times 2, let's say, then you already have this, but I can increase this, so I can say times, or to the power of k, and then if I set my k going from 1 to 200, let's say, now I can make a pulse like this, which is exactly what I want, right? I want the glitter to be off all the time, and then it just pulses on real quick. So let's have a look at that. So I do a power around this, and then I say, okay, it's to the 100th power. And so now all my glitters are off, and then they just kind of pulse on shortly. And then they're off for a long time again. Okay, now obviously I don't want all those glitters to go at the same time. I want them all to be phase shifted so that they appear more random. And for that I can just change the phase by adding something here, by adding some offset. So I could add this n offset, but n goes from 0 to 1, and in order to shift the entire phase of a sign you need to shift by 2 pi, or by tau. So I could multiply my n by tau, so tau is 2 pi. Let me just also make that. So define tau is 6.283185. That's just 2 times pi. Where am I? Over here. So I could do this, but this is not the full solution. Although it kind of looks like it, but here you see that right now, like the big sparkles come at the same time and the small sparkles come at the same time. And that is because that random number that we use to derive the phase is the same random number we use to derive the size. So we can't do that. So this needs to be a different random number. And in order to expand one random number into another random number, what I like to do is just take the fract of it and then multiply this by 10, let's say. So if you multiply this by 10, it basically just shifts the decimal point 1 over. And then you take the remaining decimal part as the new random number. And if you do that, then it gets a lot more random looking. Okay, so that's for the sparkle. So let me see what it looks like if I put this on here. So let me just get back here. And then here, let's add some sparkles. So I can just say call plus equals glitter of some 2D position, which is p.xz, because the xz is that's the ground plane. And so let's see what that looks like. And then we have a bunch of sparkles, although they're not terribly bright. Also, they're too big, and also they're not moving. So in order to get them to move, I can just say p.z plus equals or minus equals. Hang on, I think it's minus equals. So I have to move the ground there the same way as I moved it inside of the getDist function. Yeah, over here it's minus t. So let me add that. Minus equals t. So that moves it. Now I want to make them smaller. To make them smaller, I could just multiply this by some larger than 1 number. That doesn't look terribly good. Okay, let's just reset this. So some of these pseudo-random number generators, they go due to floating point precision. Like after a while, they kind of start becoming not so random looking. If that happens, then it's usually after a couple minutes. So I just reset this. If you don't want that to happen, then you can do things by making sure you never throw a number into it that's too large, or coming up with a different hash function. But for now, I'm just going to leave it like this. And then also, I want this whole thing to be brighter, because these sparkles aren't particularly bright right now. So let me just multiply it by 5, let's say. Well, that's too high. By 3. Yeah, something like that. That could work. I see that some sparkles are showing through on the outside of the ball. So let me just make this slightly larger. Make sure that that doesn't happen. And then, so sparkles are obviously view dependent, right? They change based on your viewpoint. And so in order to do that, we should change this glitter input based on where my camera is. So the camera is ray.x, like rayOrigin.x plus rayOrigin.y plus rayOrigin.z. So if I add that, so now if I move no, what am I doing? No, this is like, we don't want this. Hang on, let me just go back here. We need to expose the phase parameter. So over here, the glitter, like this, this over here needs to be exposed to the outside. So let me just call this A, and then go over here, float A. And so A is just the phase of the glitter, right? Or the phase of the sparkle. And then I go inside of here, and now for the phase I do that rho.x plus rho.y plus rho.z. And so now, if I move the camera around, you see that it sparkles, which is more realistic. Now, another way to write this, which is perhaps a little bit neater, is to just use a dot product. So if I do dot row and vec3 with 1, that's basically the same thing, because this is rho.x plus times 1 plus rho.y times 1 plus rho.z times 1. And now I can make it faster by saying times 2, for instance. So it gets more sparkly. Okay, now and we also want to add this this offset as well to the sparkle offset. So plus t or minus t, it doesn't really matter. Let me just make it minus t. So let's have a look. Okay, so now that doesn't go too fast. I want it to be much more like turn on and off faster. So I'm gonna multiply that. Yeah, so that's a lot faster. I still don't think this is terribly bright. Let me just tweak this a little bit. Times 4 here and times 4 there, maybe. Anyways, like these kinds of things that are like tweaking to make things look good, like that's what takes a lot of time in shader, or in like what we're doing here. So I will leave the fine-tuning of this thing to you, so you can tweak it to your heart's content. But one thing I do want to do here though for the glitters right now, which is, and maybe make them a little bit smaller still. Which is to make sure that there's no glitters inside of the shade, right? Because it, like, if you're in the shade here, and actually maybe I should make these. Maybe I should make the shadow a little bit more defined as well. So for that, I'm not entirely sure what I can do for that. 0.5. I can do 0.5, but then it's very hard. Yeah, 0.01, I guess. Also, it shouldn't go all the way black either. So let's make it. Let's make it times 0.9. So like this shadow goes from 0 to 1. If I do it times 0.9, it goes from 0 to 0.9 and then plus 0.1. So now it goes from 0.1 to 1. And so that just makes my shadow a little bit lighter. And then over here I can just multiply this also by shadow to make sure that my sparkles do not show up inside of a shadow, right? Because the idea of a sparkle would be that there's some micro facet here that is reflecting directly towards the light source. But if it's in a shadow, then that can never happen. So a sparkle should not be visible inside of a shadow. So let me just take that out. Okay, so now we have a bunch of sparkles that sparkle when we move around, but they don't show inside of the shadow, which is great. All right, next up, let's add a light on the inside of this thing. And so for that, I'm just going to put a 2D light on top of this, because another beautiful thing about this is that we're looking directly at the origin. The origin is, or the center of the ball is exactly in the center of the screen, always. So when I rotate around, it's still there. So I can use I can make use of that fact by just making a 2D effect for the light in the center here. And for that, I'm going to have to use again a center distance. So let me call CD, and let me in this case do the dot product of the UV with itself, which is the same. So the UV is also 0 in the middle, right? So dot UV do UV just give me the squared distance to the center. So I could also do length of UV, but this is just the length of the UV squared. Because if you write out the dot product, it kind of makes sense, right? It's UV.x times UV.x plus UV.y times UV.y plus the z plus times the z, which is just Pythagoras without the square root around it. So this is the distance, center distance squared. Okay, and I can use that to make a light. So I'm going to say float light equals 0.05 divided by the center distance, let's say. And now let's add that, col plus equals light. And that gives me a light source in the center. And that's way too large. Let's make it smaller. That's maybe still way too large. Anyways, I added something like that maybe. Now we have an obvious problem, which is that it's in front of everything, which obviously we don't want. Yeah, so what we can do here is we can just make sure that we don't render the light when our depth that we get out of the ray march is not deep enough. Because if it's not deep enough, then we know that we hit the front there. And so what we can do for that is to multiply this by a smooth step with the distance that we get out from the ray march. So this distance is the distance from the camera to whatever point we hit. And we can say that if that is 0.2, no, we say from 2 to 1, let's say. Let's see what that does. Let me make this smaller. Let me say from 0.5 to 0. And then, now that doesn't show at all. And then let me subtract from this. Okay, that didn't work. Okay, so now it's only showing on the front and not on the back. I want the opposite of that, so I'm just going to turn these around. And now I have the light only in the middle and not on the outside, which is pretty cool. I would also want some of this light to kind of shine over the edge here. And so for that, what I could do is I could add another one here, col plus equals light. That's on top, but that one should disappear when we are close, or when there's something in between. And how do we know there's something in between? Well, we can use the same trick again that we did before, where we just sample this at the right position to attenuate that. And so for that, let me say float s equals ball gyroid of, let's think about it, it's the vector that goes from my eye to the center. We have to check if that vector, if we're right at the edge of the ball, if we're inside of the gyroid or not. And so that vector is just the ray origin. Yeah, it's just the ray origin. So it's the normalized version of the ray origin. So like this is a vector that goes from the origin of the scene, which is in the center of the ball, to the ray origin, which is the camera position, which is my eye. So it goes from the center of the ball to my eye, but that vector is too long, obviously, so we need to trim that vector so it ends up right at where the ball is, so that's why I normalize it like this. And now, if this is positive, then I'm outside and it should show. If it's negative, it should not show. So I can just multiply this by a smooth step, and then I should probably do 0.1 and minus 0.1. Let's see if that works. Not really. Let's make this a lot smaller. Okay, so it's showing there now. Let me just turn this around. Okay, so now it kind of disappears when we occlude it too far. Except for over here, because it wants to be extra difficult. Let me change these values a little bit. Okay, so now that goes really fast. I want it to go a little bit slower, so let's make this a bit larger. So it starts fading out. Yeah, I think this could work. So now we have some shine that goes over top, which is pretty cool. All right, now the next thing that I'm going to do, let's see here. Oh, time flies when you're having fun. The next thing I'm going to do is I'm going to make some. Yeah, now maybe I should do that next time because we're already kind of almost half an hour in. So let me leave that for next time. So, anyways, I hope you liked this so far. Let me just put it over here. Yeah, I hope you liked it so far. If you did, please like, comment, subscribe. I hope you make something really cool with this. If you do, post it on a Facebook group or let me know about it another way. Reach out to me on Twitter or on my email or on the comments below. Anyways, I hope you liked this and I hope to see you next time.